All right, this is Pre-Calculus A, Unit 3, Lesson 1, Analyzing Functions. We're going to take a look at several concepts, including parts of the domain over which the function is increasing, parts of the domain in which the function is decreasing, parts of the domain in which the function is constant, as well as x and y intercepts, and maybe a little bit about what those mean in certain contexts. Okay? So analyzing functions for increasing, decreasing, constant, and intercepts. All right. So let's take a look at this particular function that's on the screen. It's a piecewise function. The first section here is in fact a parabola opening down with a vertex at -6, 4. And it is applied only as x is less than or equal to -6. This next part is a horizontal line, y equals 4, and it's going to go from -6 to -2 on the x-axis. Then we have a parabola lying on its side, the bottom half of a parabola, the square root function, centered at -2, 4, and going from -2 to +2. And we have a parabola again, opening upward, centered at 4, -2, but only going from x for x greater than 2. Okay. All right. Let's bring this in. I've already graphed this in Desmos. All right, and you can set domain restrictions by putting them in braces in Desmos. Really kind of a useful feature. But you can see that all of these are contiguous. That means that it's constant. I can draw it from left to right. I can draw it without picking up my pencil, so it is continuous. All right. Now let's answer the first question: where is this function increasing? I don't know if you've ever played it, but my kids have played on their tablets and so forth. These little games where you're driving a car and it shows just a two-dimensional drawing or a picture of a mountainside or whatever, and the car is going along and they have to go over jumps and things as the scenery moves across behind them. They are moving in one direction, usually from left to right, right? Usually from left to right. And that's the same thing here. We consider this a terrain ride going from left to right. So if this were a roller coaster or a car driving app, and I'm driving from left to right, I would hit the red section first, going up, 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 and then I would reach the top, and then I would go flat. So it's increasing in the red section. It's constant in the blue. And then in the green, it's decreasing. And then in the purple, it's decreasing until it reaches the point at 4, -2, and then it is increasing. Okay, so let's analyze this function for those things. So it is increasing. Let's add a note. Put it down here. Okay, increasing. It's increasing from x less than 0, so less than -6, less than or equal to -6. Okay, -6. It's increasing there. So in set notation, we would say parentheses infinity, negative infinity, to -6. Okay, union. And then, where is it increasing? It's also going up. It's level, going down, it's level, and then it starts going up after 4. So from 4 to infinity. 4 to and positive infinity. That's where it's increasing. Where it's decreasing, going from left to right, whoops. Where it's decreasing, I need to insert a note. Decreasing is where it's going down as we ride from left to right. That's the green and the purple all the way up to the point 4. So it's decreasing. It's decreasing from -2 to +4. Okay. Now, by the way, at 2 and at 4, it's neither decreasing nor increasing. You might say it is momentarily constant because it has a 0 slope, right? It's flat, it's level. Okay? All right, that's where it's decreasing, and where it's constant is at on the green. The constant is flat, right? It's not going up, it's not going down, it's constant. It's always giving an output of 4. And that happens from -6 to -2. So -6 to -2. It's constant, okay? We can also find the intercepts, the x-intercepts, right? X-intercepts are, see, it crosses at -8 and at, now here, Desmos will tell me it looks like about 2.5860, right? 2.5860, okay? We could solve a quadratic form equation to figure that out. 5.4140 are the x-intercepts, okay? And the y-intercept, there's only one y-intercept, and typically for any given function, there's only going to be one y-intercept because it only flows from left to right. Y-intercept is where it crosses the y-axis, and it seems to cross right here, 0, 2.586. 0, 2.586. Now, one thing, when you name x-intercepts, when you name y-intercepts, technically you should state the x and the y coordinates, okay, if you're labeling the intercepts. All right, so that's labeling intercepts. Now there's one more thing. We want to make sure we have a clear understanding of our definitions of increasing, decreasing, and constant. So a function is said to be increasing. Increasing. If x2 is bigger than x1, if, in other words, if I'm to the right, if I move to the right, the function goes up. That must mean that f of x2 is greater than f of x1. Okay? If x2 is greater than x1, in other words, if we're to the right, then we have gone up. F of x2 has to be greater than f of x1. Okay, hopefully that makes sense. If we're going up, a bigger x value means a bigger output value, a bigger y value. If it's decreasing, the opposite is true. If x2 is bigger than x1, if we're moving to the right, then the function must go down. That is, f of x2 must be less than f of x1. Okay, so if we put in x1 and x2, we have gone down. That is, the output of the second f of x2 is less than the output of the first f of x1. Okay, and again, hopefully that makes sense. A function is said to be constant if we put in two different x values, x2 greater than x1, and f of x2 equals f of x1, okay, over any part of the domain. So in other words, we put in two x values, x1 and x2, and the output doesn't change. F of x1, f of x2. Okay, so that's the more formal definition of increasing versus decreasing. Okay, so hopefully that makes sense. You'll get more detail in the lesson.